The next few slides discuss the literacy demands of the science classroom. So, what are the literacy demands in the science content area classroom? Disciplinary literacy in science. Science involves activating and using prior knowledge. It's important for students to use what they know to set the stage for learning. This helps formulate questions to discuss and inquire. Science also involves logical reasoning to connect evidence with conclusions. Students must be able to think reasonably about the evidence collected to come up with scientific conclusions. Science also involves group discussions to formulate questions and communicate explanations. Discussion and collaboration is key in science. In the Content Matters Chapter 5, it reviews how some teachers use discussion in a great way to enhance thinking and learning. Science also involves learning through experimentation and inquiry, and a lot of reading, writing, speaking, and listening skills for full understanding of the scientific content. Here are some of the literacy demands in science for reading, writing, speaking, and listening. For speaking, students must be able to join in discussions, express ideas and opinions, argue constructively, and use content-specific vocabulary correctly. For listening, they must be able to listen to ideas and opinions of others, identify main ideas and supporting ideas, listen and take notes. For reading, students must be able to recognize content vocabulary, read from a variety of scientific sources, locate and organize information, skim and scan the text, and interpret graphs and visuals. For writing, students must be able to write to share findings, use vocabulary appropriately, create tables, diagrams, and other visuals, be able to construct a report, and describe and explain procedures. Now, some of these can even be challenging for the effective reader when you are using an enhanced text such as a scientific text, and the teachers must be able to teach students how to use these skills to understand the scientific concepts. Strategies used in the science classroom. Now, in the article called The Challenge of Content Area Literacy, a Middle School Case Study, it reviews a few of these strategies that teachers can use. The first one is called HEART, and HEART asks yourself how much I already know about the topic, establishing a purpose for studying, asking questions as I study, recording answers to my questions, and then testing myself. And in the article, it states that students really felt this was a great way to help them learn, organize, and remember information. Students must also be able to compare and contrast, sequence, use cause and effect, and opinion and proof. Now, these are strategies learned in the reading classroom that must also be used and taught in the science classroom to help gain full understanding. Teachers must also show students study skills and how to study to help them learn information. It also talks about raft. And raft, students need to think about what their role is in the experiment or lesson, who is the audience they are presenting to, what format do they need to use to write up their response, and what is the main topic of discussion today. And students also used book shares and journals in the science classroom to help them understand the scientific text more easily. Now, teachers must be able to implement lessons using well-developed instructional materials around the important scientific concepts.
The next few slides describe the text that are typically used in science classrooms, as well as the strategies for instruction, the issues with these strategies, and then students' attitude. The texts that are typically used in science classrooms. Science teachers have used textbooks alone to teach their students the content in the science curriculum. Teachers assign chapters from the books for students to read and expect them to use only the text to learn information. There are a number of strategies that are typically used in science classrooms. These include teachers giving lectures and expecting students to understand the science text, students reading chapters in a textbook, and then answering multiple choice questions that go along with the information they have read. Teachers do a lot of telling students the information, and then students are memorizing science facts. In some science classrooms, students are participating in few laboratory experiences and just going through the motions. They're collecting the numbers and the data only to fill out the chart and complete the assignment to turn in. There are a number of issues with this type of instruction. The instruction does not support students connecting science concepts to their own lives. It's a one-way communication with teachers doing all of the explaining and students listening and memorizing the information that the teachers are giving them. Students often forget the information after they have memorized and taken a test on this. At the end of the year, they're glad that the science class is over and the information they can forget about. This type of instruction also affects students' attitudes. The teachers are presenting to an inactive audience who are just listening to the teacher talk. The students begin to believe that science is too hard to understand. For some students, they then think that science is only important to the brightest students in the class and does not apply to everyone. The students are often relieved when the science class is over at the end of the year. On this slide, I have my references below that I used, the Content Matters book, as well as an article, Strategies for Teaching Science, What Works?
What are texts that can be integrated into the content area of science? Text, as we know from Lecture 2, can be oral, written, or visual. And in the content area isn't anything. There needs to be text of various genres, varying levels, and a balance of text to integrate into the curriculum. My resources are here at the bottom. Trade books were by far and large the most researched and documented effective text to be integrated into the content area. They can be used as a tool to enhance the quest for knowledge and expertise. There needs to be a balance of text to integrate into the curriculum. In the trade book category, there could be big books, novels, storybooks, poetry, pop-up, inquiry, informational, science fiction, discovery, explorations. There could be reference books, field guides, how-to narratives, expository, explanation, biography, and journals. There could be science papers, trade books, stories, poems, information books, handbooks, field guides, graphic representations, and narrative text. The sky's really the limit, and our next presentation will include the other types of new literacies. Writing helps to model scientific language and can be used across the curriculum to be an effective link between the language arts and science. Journals are often used. They help to reflect and develop scientific ideas and are the true work of scientists. Personal stories help to internalize new ideas and make them their own. Skits, songs, and poetry help to tap into the multiple intelligences. Graphic organizers, such as the semantic feature analysis, helps to organize information and data. Diagrams, which could be words and pictures, help to illustrate a scientific concept and may be used as something as simple as a bumper sticker to find ways to maybe save water or help the environment. Again, reading, interpreting, and producing text are fundamental practices of science. Narratives help to record emotions and attitudes. It could be a diary, a journal, a learning log, or conversations. Descriptions would be documentation of events. It could be classifications, reporting, noticing patterns. Explanations would be the link to establish ideas or models with observed effects. Instructions would be the directions. Could be a series of steps, procedures in a manual, an experiment, a recipe. And argumentation would be a proposition to persuade. It could be in the form of an essay, a discussion, a debate, a report, or a review. This slide lists some resources that were mentioned in my articles. The National Science Teacher Association puts out a list every March of suggested high-quality trade books. The American Association for Advancement of Science also has a list of excellent science books. And the Orbis Pictus Award for Outstanding Nonfiction for Children at the National Council of Teachers of English has a list as well. The last thing is a checklist for choosing children's books, which was referenced in one of my articles. It is published by Rice, Dudley, and Williams. It doesn't appear that the link has taken effect, but they did stress in the article that, as with textbooks, trade books sometimes can be inaccurate, and this is a checklist for making sure that your trade book selection is accurate and it is high quality literature, as stated in Literature for Science Connections in the Classroom.
These next few slides answer the question, how can new literacies be integrated into the content area? New literacy is often recognized as the incorporation of technology into the classroom to broaden students' exposure to content area and modern forms of information distribution. Here are some of the common approaches to using new literacies in the science classroom. They will use equipment to collect data, media to deliver content, interactive tools such as simulation or games to enhance learning, network technology to perform information research, productivity tools to create reports for findings. The definition of literacy has evolved to include the ability to use digital technologies to identify questions, locate information, evaluate the information, synthesize the information to answer questions, and to communicate the answers to others. This set of skills and knowledge, with the incorporation of digital tools in research, is called new literacies. The tools used to support the development of new literacies are called the Information and Communication Technologies, or ICTs. ICTs allow teachers and students to retrieve information beyond the textbooks and to reach out to a worldly audience outside of the classroom. Some examples of ICTs that can be used in the science classroom are word processing, spreadsheets, Google Earth for a virtual globe, social networking tools such as Edmodo, YouTube, threaded discussions, blogs, wikis, Nings, WebQuests, 3D simulations, web editing, and movie production. The new literacies now shift from using technology as learning from tools to learning with cognitive tools. Students can now take on the responsibility of producing information through a variety of tools and technologies. A literate person needs to be able to read and write and learn with texts that have multimodal elements such as print, graphic design, audio, video, gesture, and nonstop interaction. Teachers need to at least have a basic mastery of reading and writing using different modes of communication. On this slide, you will find an example of using new literacy skills in the science classroom. First, the teacher will provide background information about the content area or topic. Then, the students will use search engines like Google to look for articles. The students will then share their articles on social networking sites like Edmodo with their classmates.
The teacher will then provide the students with reliable cyber databases, allowing the students to collect public data. With the teacher's guidance, the students will generate scientific testable questions and hypotheses that can be answered using the scientific data collected and shared on Edmodo. And then the students can use a spreadsheet to log information and to examine their findings. The students will then use images, videos, and other hyperlinks as part of their final report, which they will then share with an audience. And this information was from an article called Middle School Science Teachers, Confidence and Pedagogical Practices of the New Literacies. Next, we have the benefits of using new literacies in the classroom. The Common Core State Standard Initiatives states that students in all content areas will need to develop and to be discipline literate with the 21st century skills. With the integration of new literacies, students will become familiar with various technology tools. Student interest. The students in the new literacy classroom engage in a mix of individual and collaborative activities. The students are more engaged with the material. Real-world preparation. The students are being prepared for the real world and are learning skills such as critical thinking, problem solving, decision making, digital citizenship, and technology operation. Next, you will learn how a literacy coach supports the science content teacher.
How can a literacy coach support the science content teacher? This is a case of perfect symbiosis. Agriculture, art, dance, English, mathematics, music, physical education, science, social studies, and theater education professors possess the deep content knowledge necessary for successful navigation and creation of texts in these disciplines, while the literacy professionals bring the knowledge of the text, the comprehension, and the composing processes. Together, we can find common ground. Victoria Gillis, a former science teacher and now literacy professor, made this statement in the article, Disciplinary Literacy, Adapt, Not Adopt, from the Journal of Adolescent and Adult Literacy. In her article, she states the need for content teachers and literacy teachers to work together to adapt reading strategies to fit the content areas rather than simply adopting reading strategies. The literacy coach must utilize strategies that fit the thinking of the science content area. It is essential that a literacy coach recognize the thinking of a scientist and respect the cognitive processes of a scientist when helping the content teacher. Science and literacy instruction must operate simultaneously for maximum academic growth. The science content should determine and should drive the literacy process that is being used for meaningful instruction by the content teacher and the reading coach. The literacy coach will foster effective disciplinary literacy practices. Effective instructional practices will explicitly link data, the evidence the students collect, to making inferences and drawing conclusions in science. Gillis states this in her article. Practices will highlight multimodal reading and various text structure in science. The content teacher and the literacy coach must work to teach students how to look at diagrams and read them to make meaning. They have to teach them how to read graphs, experimental results, look and analyze photographs, learn how to read slides and use slides efficiently in class. They must teach students to look and read equipment and many other forms of text depending on the nature of the science being studied. Instruction should attend to science vocabulary. Students have to engage in activities that are going to teach them how to make meaning of this specific vocabulary. Practices will engage students in inquiry-based science learning. This is huge in science, this inquiry process. The kids must be creating questions that drive their thinking. They have to engage in labs and experiments that too will further their thinking. and it has to be meaningful to them. Effective instructional practices will teach students to write scientific explanations for their findings. This is vital to their understanding of scientific principles. Practices will utilize discipline-specific reading strategies that support the understanding of the content knowledge.
The literacy coach must offer support. A supportive coach will need to provide the necessary scaffolding to help and assist all readers and all learners. This means a coach needs to model, do think alouds for the students, use visual learning charts, and respect cultural language differences in the learning process. The coach needs to allow and provide time for student collaboration and discussion. This is huge in science instruction. The students need time to listen to each other's prior knowledge and use it to further their thinking processes. They need to talk and discuss the questions they want to pose for science discovery and science inquiry. They need to compare and contrast results and data that they collect to extend their thinking. A coach needs to suggest complementary reading material that supports diverse learners. And a coach will want to recommend formal as well as informal assessments to be used in class to assist with instructional practices. A coach will also want to teach, model, and hold students responsible for using accountable talk practices. Accountable talk practices were mentioned in the Content Matters book, the chapter on science. They refer to phrases the teacher and students use that ensure purposeful, coherent, and productive group discussions. They're questions that just lead to deeper thinking. A coach will recommend and implement engaging activities with the help and support of the expert content teacher. The coach will need to teach how to read critically, data, charts, and text, of course. Finally, the coach will observe and provide ongoing feedback to the expert teacher as well as the students.